Hi, I'm Asa Sharma, and here is my card, and my ZID is 5444661. So my presentation will be about the classification of galaxies, so let's get started with it. Now, galaxies are the fundamental building blocks of our universe, exhibiting remarkable diversity in shapes and sizes. Now, in this presentation, I'll delve into the processes that lead to the formation of different galaxy types and also draw insights from observations of various clusters. And through this experiment, we'll see how the color of galaxies provides clues about their past. Now, how are galaxies formed? Well, our current understanding is that galaxies are formed from small density fluctuations in the early universe after the Big Bang. Gas clouds collapsed under gravity, leading to the formation of the first stars. And over time, galaxies grew larger through mergers. Galaxy evolution is influenced by environment, collisions, and internal processes like starbursts. Now, spiral galaxies are formed from rotating gas disks with ongoing star formation, while elliptical galaxies are often formed from galaxy mergers where star formation has largely stopped. On the other hand, irregular galaxies are heavily disturbed due to gravitational interactions. Now, let's try to distinguish the various types of galaxies, starting with spiral galaxies, which will have blue arms with young stars and a yellow bulge of older stars. And then there are elliptical galaxies that are mostly yellowish or red, and they're made of old stars with very little star formation, new star formation. And now there are irregular galaxies that tend to have chaotic shapes and blue regions. Now, here is my answer for question 4. So, when observing the Coma and Hercules clusters, spiral galaxies were mainly found in blue colors, especially in the spiral arms, indicating young, newly formed stars. The central bulges, however, appeared yellow or white, showing older stars. In comparison, elliptical galaxies appeared mostly yellow or reddish, meaning they are made of older stars with little or no new star formation. Overall, spiral galaxies show active star formation, while elliptical galaxies are older and more passive. Then for part D, the spiral galaxies, they have a yellow or white bulge, which are a clear indicator of older stars, while the blue disk indicate younger stars and active star formation. Now, looking at the NGC 6745 image, the bright blue regions, as we can see in the photo, along the distorted arms, indicate areas of recent star formation. These young, massive stars show that when galaxies interact, gravitational forces compress gas clouds and trigger intense starbursts, creating new stars rather than just causing destruction. Now, here are my results for question 6. And now, of course, the numbers I've counted are not exactly reflective of the actual number contained in the images, but this is just a rough counting I've done of the bigger galaxies. So when I classified galaxies from 3 clusters, namely the Fornax cluster of galaxies, an astrophysical robbery, and the spiderweb protocluster, I noticed that most galaxies were elliptical and only a few spiral irregulars were present. Now, looking at the Hubble Ultra Deep Field, this is a really beautiful image, by the way, because for context, this photo was taken from about 13 billion light years away, which is really old. And it shows signs of the early universe. Now, looking at the results again, this is a rough counting I've done, but looking at it, we see that there is a higher ratio of spirals to ellipticals and irregulars to ellipticals as compared in the previous slide. Now, let's compare the results of question 6 and question 7. So, both the clusters and the Hubble Ultra Deep Field showed spirals, ellipticals, and irregulars, which goes to show that all types of galaxies are common across the universe. But the Hubble Ultra Deep Field had a higher number of spirals and irregulars as compared to the clusters. This implies that denser, older environments encourage galaxy mergers and transformations into ellipticals, while in the earlier and newer universe, galaxies were still forming and evolving. It also supports the idea that the environment heavily influences galaxy evolution. Now, question 9 asks, what would the Hubble Ultra Deep Field look like 10 billion years later? And what I think is that many of the small irregular galaxies would have evolved into more structured spirals or ellipticals. There would be fewer irregulars and possibly more mature, wetter galaxies with new star formation, and the universe would appear more mature and settled. Now, this experiment has taught me a lot, like how to classify galaxies using their shapes and colors, and how these features tell us about star formation and age. I also understand how galaxy collisions can trigger new star formation. Additionally, by classifying different clusters, I saw how environment and time play a key role in shaping galaxies. Overall, it made me realize that every galaxy is unique, evolving over billions of years, and just like humans, where no two galaxies are exactly the same. Thank you.